Okay, so in this video we're going to talk about graphing systems of linear inequalities, okay? And when we're graphing systems of linear inequalities, we have to be very neat, okay? Because it's really easy to get messy, okay? Because when we're graphing systems of linear inequalities, what we're doing is we're graphing multiple inequalities in the same coordinate plane, and the solutions are going to be where all the shading overlaps. That's where the solutions to a system of inequalities takes place, okay, where all the shading overlaps. So sometimes it's a little difficult to determine where the shading overlaps if we're not being very neat. So make sure that we're being very neat and clean with all of our work, okay? So we have a system right here, y greater than 2x minus 4 and y less than or equal to negative 5 halves x plus 3, okay? Now, if your inequalities aren't in slope-intercept form already, I highly recommend that you do so right away before you start graphing anything, okay? So in these cases, they're already going to be in slope-intercept form, but if they weren't, make sure that you get them in slope-intercept form first, okay? So I'm going to go ahead and graph this first inequality in this red, all right? So our slope is 2, so we're going up to right one, up to right one, and our y-intercept is 0, negative 4. So we can go ahead and graph that. So 0, negative 4, up to right one, up to right one, and I'm just going to kind of keep doing this until I run out of room. So up to right one, and I can go backwards down to left one, down to left one, down to left one, okay? And remember, with inequalities, there's only two differences. We got to think about whether it's a solid or dashed line and where the shading is going to be. And since this one is not or equal to, I'm connecting this with a dashed line. So I'm going to connect these with a dashed line. And there's my line. And then I got to think about shading. Now I got to think about shading. Well, since this is greater than, I'm going to be shading above, okay? And I'm just going to actually kind of lightly, I'm going to try to lightly shade where that would be, okay? Because we're going to need to be able to see where the shading overlaps. We're going to need to be able to see where the shading overlaps, so I need to just do it kind of lightly. Okay, so that's my first graphed, okay? So that's my first one. And I'm going to do this next one in purple so they can kind of stick apart, okay? So in this case, we have the slope for this inequality is negative 5 halves. So we're going to go down 5, right 2, down 5, right 2, okay? And the y-intercept is 0, 3. So I can plot 0, 3, and now I can use my slope. Down 5, right 2, down 5, right 2, and I don't have any more room on that side. I can go backwards. Up 5, left 2, and that's all the room I have. And now, since this is or equal to, I can connect these with a solid line. So I can connect these with a solid line because this one is or equal to, okay, since this one is or equal to. And now, since this is in slope-intercept form and it's less than, that means I'm going to be shading below this line. So I'm shading below this line. So that's where my shading is, okay? So now I have to look at my graph and see where the shading overlaps, and that's where all my solutions are going to be. Well, as you can see, all the shading overlaps in this big region over here, okay? All the shading overlaps in this big region over here. So that's actually going to be where all of my solutions lie, okay? So we need to make sure that it's abundantly clear we know exactly where those solutions are. So we can either erase the rest of the shading, or we can just kind of like really heavily shade in. We can heavily shade in the rest of the graph, and that's what I'm going to actually elect to do. So I am going to heavily shade where the solutions are, and that's in this region here. In this region here in black, that's where all of our solutions are going to be. So a possible solution to the system, could be something like negative 3, 0. That's in the double shaded region. That's in the overlap shaded region. A solution could also be like negative 5, negative 2. that's in the double shaded region. It could be something like -10, +10, or -9, +2. Okay, so all of these are in that overlap shaded region. So that's where all the solutions are going to be. Okay, so that's how we graph a system of linear inequalities. We graph each one individually, and it's where all the shading overlaps. Okay, so I just want to cover one more example with you guys. So let's go ahead and take a look at this system here. Let's take a look at this system here. So in this case, we have y greater than or equal to 3x minus 2, y less than or equal to 7, and x greater than -4. So in this case, we actually have 3 inequalities, so we're going to have 3 lines. So if you notice in the previous problem, we had 2 inequalities, I had 2 lines. In this case, this system has 3 inequalities, it's going to have 3 lines. Okay, so I'm going to go ahead and do this first one in this green. The slope of this one is going to be 3, so I'm going up 3, right 1, up 3, right 1, and the y-intercept is going to be 0, -2. Okay, so I can go ahead and plot this. So y-intercept is 0, -2, and the slope of 3. So up 3, right 1, up 3, right 1, up 3, right 1, and up 3, right 1. Okay, and I can go backwards, down 3, left 1, and down 3, left 1. And now this is or equal to, so I'm going to connect this with a solid line. Connect this with a nice solid line. And since this is greater than, okay, I know it's greater than or equal to, but since it's greater than, that means we're shading above this line. So all in here. This wasn't a good color choice. I'm going to go ahead and do something a little bit brighter. That's a little bit better. So I'd be shading above this line. So that's my first inequality graphed. Okay, now I need to go ahead and look at my next one. So my next one I'll go ahead and do in a pink. All right, so you can see that this one is just y less than or equal to 7. Okay, and this one, it is in slope intercept form. The y-intercept is at 0, 7. Okay, and some people get a little bit confused as to what this line is. Well, another way you can think about this is y less than or equal to 0x plus 7. Okay, which means that we have a slope of 0. So whenever we have y, okay, y and then equals to or greater than or less than just some number, that's going to be a perfectly horizontal line. Okay, so this is going to be a perfectly horizontal line because y is 7 here, y is 7 here, y is 7 here, y is 7 here. Okay, so it's going to be a perfectly horizontal line, and since it's or equal to, it's going to be a solid horizontal line. That's going to be a solid horizontal line. Okay, and now in this case, this is y less than or equal to 7. Well, that means we're going to shade below. Okay, and you can also think about it is, where is y less than or equal to 7? Well, when y is 4, when y is 0, when y is -5. So I'm shading below. And you could probably already start to see where our solutions are going to be coming from. So far, they're stuck in this region right here. Okay, so I'm going to disregard this region and this region because here's where the overlapping is so far. Okay, so that's our second inequality. Our third one, I'll do in blue. This one is just x greater than or equal, or excuse me, just x greater than -4. This one has no y. It just has an x. The x-intercept is -4, 0. Okay, and you can kind of think about this one. Where is x -4? Well, x is -4 here. X is -4 here. And x is -4 here. So whenever it's x and then equals or less than or greater than some number, that's a perfectly vertical line. Okay, and since this is not or equal to, this is going to be a dashed vertical line. This is going to be a dashed vertical line, just like this. And this is x greater than -4. So some people get a little bit concerned, like where's above, where's below. With this, with the vertical line, we don't think about it in terms of that. Where is x greater than -4? Well, when x is -2, 0, 3, 7, 10, so that's shaded to the right. So all of this will be shaded for x greater than -4. And now we should be able to see exactly where all of that shading overlaps one another. Okay, notice all the shading overlaps in this big region here. So this is where I would want to heavily shade. So all of the points in this particular region would be points that would make this system of inequalities true, okay? So the point like -2, 0, -3, +6, 1, +4, -3, -4, okay? All of these would be points that would make the system work, okay? So that's how you graph systems of linear inequalities. Definitely practice that. It can be a little tricky. Just make sure we're being very, very careful and very, very neat with our graphs. And I recommend that you definitely do it in pencil so you can actually erase this stuff, okay? So that's graphing systems of linear inequalities. I'll go ahead and make a video about how we can apply this with certain situations and word problems. Make sure that we check that out.